Welcome to The Explainer. Today, we're tackling a huge question in tech, one that could save you millions. We're talking about the real cost of generative AI and how you can power it without, completely emptying your wallet. So, here's the game plan. First, we'll look at just how crazy expensive AI can be. Then, we'll break down the two main ways to run it. And finally, this is the fun part, we're going to dive into the actual numbers to find that magic moment where the math flips and you start saving some serious cash. All right, let's just get right into it. The first thing you need to understand is the sheer scale of the problem we're talking about. I mean, generative AI, it's a game changer, for sure. But that transformation, well, it's powered by some of the priciest hardware you can imagine. And when I say pricey, I mean, wow. To give you some perspective, let's say you wanted to train a big, new large language model on a major cloud platform. That could, hypothetically, set you back almost $500 million. Yeah, just for the compute time. That one number, that tells you everything you need to know about why the stakes here are just so incredibly high. So that massive cost, it forces you into a really fundamental choice. And honestly, it's a choice we've all faced before, just on a much smaller scale. It's the classic buy versus rent dilemma, but for AI. Do you buy and build your own stuff in-house, what we call on-premise, or do you just rent the computing power you need from a big cloud provider? Now, let's break that down, because this is where it gets interesting. If you go the on-prem route, you're looking at a huge upfront cost, right? That's your capital expenditure. But after that, your day-to-day costs for power, cooling, staff, they're more manageable. The cloud, on the other hand, completely flips that script. You pay nothing upfront, which is awesome. But you're now on the hook for an ongoing subscription fee that can just keep going and going and going. So really, it all boils down to a single trade-off. You have the big, one-time investment for lower costs down the road. That's on-prem. Or you have zero upfront cost, but a potentially massive, never-ending rental bill. It's a classic high upfront versus high long-term cost situation. Okay, enough theory. Let's get to the good stuff, the data. Let's figure out where that tipping point is. You know, that magic moment where buying your own gear actually starts to make a ton of financial sense. So, the big question is, when does buying finally beat renting? To figure this out, we're going to use a real-world example. We're talking about a super powerful server, the kind of machine that's an absolute workhorse for serious AI. Think of a box loaded with 8 top-of-the-line H100 GPUs. Okay, first, let's talk about the price to buy this beast. And prepare for some sticker shock. To own this system yourself, you're looking at a cost of around $833,000. Yep, that is the big, scary, upfront investment we were talking about. But what about renting? What's the cloud equivalent? Well, to get that same amount of power from a major cloud provider, you'd be paying about $98 an hour, almost $100 for every single hour that thing is running. Okay, so you've got the huge upfront cost versus the ticking hourly meter. And this is where we find the break-even point. If you're paying the standard on-demand cloud price, that $800,000 server pays for itself in just under a year. Think about that. Even if you get a discount for committing to a 1 or 3-year plan on the cloud, you're still breaking even in about 15 to 22 months. And after that point, every single minute that machine is running, that's money you're putting back in your pocket. Right. So once you pass that break-even point, the savings really start to pile up. And I mean dramatically. This is where we need to zoom out and look at the long-term financial impact. So what does this look like over, say, a typical 5-year lifespan for a server? Let's imagine you're running this system pretty much constantly, 24/7. Maybe you're using it for something like inference, where a trained AI model is constantly making predictions for your users, a really common sustained workload. Whoa. Okay. The difference here is just staggering. Look at this. The total cost for the self-managed system over 5 years, that's including the big initial purchase plus all the power and cooling, comes in at about $870,000. Now look at the cloud. For the same thing, you're looking at over $4.3 million. It's not even in the same ballpark.
So what's the bottom line? That's a saving of over $3.4 million. And remember, that's for one single server. It's just a massive, undeniable financial win for owning your own gear when you have a predictable, long-term job for it to do.
Okay, so saving millions of dollars over 5 years sounds fantastic, right? But how does that actually help you make a decision today? Let's boil this down to something really practical and actionable, your daily tipping point.
Yeah, there's a really useful concept here called the hourly utilization threshold. It sounds a bit technical, but it's super simple. It's basically the answer to this question: what's the absolute minimum number of hours per day I need to use this system for buying it to be cheaper than renting?
And you know what? The number is probably a lot lower than you think. For the server we've been talking about, that tipping point is only about 5 hours a day. That's it. If your AI workload is running for more than 5 hours a day, the math says you're better off owning the hardware. Anything over that is just pure savings. So where does that leave us? What's the big takeaway here? It's definitely not that the cloud is bad and owning your own stuff is good. Not at all. It's about making the right choice. It's about matching the model to your mission.
So let's make it super simple. Which path is right for you? Well, the cloud is absolutely perfect for short-term stuff, running experiments, fine-tuning a model, or dealing with workloads that are really unpredictable and bursty. But if you have a long-term, predictable, sustained workload, like serving that inference model we talked about, then owning your own system isn't just an option. It becomes a financial no-brainer.
So there you have it. You've got the framework now. You know how the math works. The only question left is the one you have to answer for yourself. What's your break-even point?